Hello, everyone. Yes, you can hear me. So I am Quentin Bourgue, a cyber threat intelligence analyst in the threat detection and research team at Sequoia, a French cybersecurity company. And for the next 30 minutes, we won't talk about hacking, but rather about the bad guys. And we will explore the malware distribution through user web browsing. But first, I would like to thank the GreHack staff for organizing this event in Grenoble, but also offering me the opportunity to share my daily work to this audience. Thank you. So my presentation is structured in three parts. The first one to introduce the drive-by download attacks. The second one to expose two recent cases. The first one is the GreHack malware, and the second one is the click-fix social engineering tactic. And in my last part, I will share some methodologies and results about tracking the adversary's infrastructure. So let's dive into the core of the subject, the drive-by download attacks. So what are the drive-by download attacks? So these attacks involve infecting the system using the web browser activities. So over the last years, we observed that more and more threat actors are using the drive-by download attacks instead of the traditional spear phishing email campaigns, as they are becoming less and less successful. So concretely, what are these drive-by download attacks? So it includes the use of legitimate websites which have been compromised by malware and which are used to distribute some malware to the visitors. It also includes the use of malicious websites impersonating or faking legitimate ones. So usually the threat actors are using search engines to spread this malicious website. So it includes the search engine optimization poisoning, or also the malicious advertisements, so a technique called malvertising. And it also includes some publication on social networks or forums to spread the malicious website. So here are a few examples. The first two ones are fake websites that impersonate Facebook and the Google reCAPTCHA challenge. So they use the click-fix tactic that we will discuss later. The third one is related to malware distribution infrastructure that use fake crack software. So when a user wants to download the software for free, the user can find this kind of malicious web pages. And on the bottom, you have on the left a fake web browser update, so which is displayed on compromised websites. And on the right, a fake AnyDesk website that spread Luma and fake bat malware. So now that we introduced the drive-by download attacks, let's see why they are impactful for organizations, but also for individuals. And I will present an example for that. So in 2023, we discovered a malvertising campaign that spread a malicious website using the Google Ads. So when the user searches for the advanced IP scanner tool, he or she will find Google Ads in first result, and this Google Ads redirect to a malicious website. So this is the malicious website. It is a copy of the legitimate advanced IP scanner website. But as you can see in the URL, it is not the legitimate domain, but a typo squat one. And if the user downloads the executable, it will install either C2 framework, C2 for command and control, so Sliver or the notorious Cobalt Strike, or Python custom backdoor. And a few months after we discovered this campaign, an incident response company, the Defier report, published a report about a ransomware attack that implied this campaign. So the threat actors behind the Black Cat ransomware used the access gained by this malvertising campaign to access to the victim networks further lateralize, exfiltrate data, and deploy the ransomware. So this slide is to point out that a simple malvertising campaign that can affect every user can also lead to a more impactful attack with the ransomware attacks. So I guess everyone knows that the ransomware attacks are the most impactful financially motivated attack for the organization. And this is just an example among many others. So I just share some examples we observed over the last year. So the notorious gang that you may know, like Logbit, RansomHub, Black Cat, Blackbasta, Royal, and so on, use drive-by-download attacks to gain a foothold into interesting corporation networks. And they use for that some malvertising and SEO poisoning to spread their own payload. So either C2 framework, botnet, loader, and so on. I just presented the ransomware threat actors as they are the most known, the most impactful. But many cyber criminals use these drive-by-download attacks to spread their own malware, so either info stealers, remote access tools, loader, botnets, and more. And why these drive-by-download attacks are such widespread in the wild? So first, because they are effective, but also because some services are facilitating these threat actors' operations. So on Russian-speaking cybercrime forums, there are numerous services which are selling tools and services to other threat actors to facilitate the execution of malware distribution campaigns. So here are some examples from the Russian-speaking cybercrime forums. So first, you have the malware as a service. So the cyber criminals pay for a malware, a ready-to-use malware. And for like $300, a threat actor can buy a sophisticated malware without any knowledge in malware development or in web server maintenance. You have also the pay-per-install services, which use a lot the drive-by-download attacks to spread the malware. So for the pay-per-install services, a threat actor can buy some malware installation to other threat actors. So for 5 cents to $10, you can have your payload, your own malware, installed by another threat actors, depending on the quality of the service, depending on the location of the victim, etc. You have also the traffers teams. So the traffers are threat actors specialized in distributing malware. And the traffers use a lot the drive-by-download attacks to spread their malware. And some traffers organize themselves as a team to share some knowledge, expertise, infrastructure, malware, and so on. And you have also other services I won't detail today, just know it. So now that we introduced the drive-by-download attacks, let's see some recent cases we observe in the wild that affect our customers and many organizations in the world. So we have two cases. The first one is the ClearFake malware, and the second one is a social engineering tactic named ClickFix. So for the ClearFake malware, it's a fake update malware that appeared in September 2023. So ClearFake is a malicious JavaScript framework deployed on compromised websites, so mostly vulnerable WordPress. And this ClearFake malware is used to deliver other malware using drive-by-download techniques. So concretely, when a user browses a WordPress compromised by ClearFake, he or she will find a fake update on the website. So depending on the web browser, you can see on the left for Google Chrome, Firefox, or Microsoft Edge. And if the user downloads this fake update, it will, of course, install malware on the system. And since June 2024, a new ClearFake variant appeared, and used a new social engineering tactic. So it is the click fix tactic. Instead of a big fake update on the screen, it displays a pop-up which indicates to the user that there is an error, so a fake error on the web browser. And to fix this error, you should execute a command in your Windows terminal. So now let's see how does the ClearFake framework work. So this figure is a bit complicated, so I will explain step by step. So first, the user visits a website compromised by ClearFake. So the website includes some JavaScript pushed by the threat actor. So this JavaScript code will then download a second JavaScript code and execute it. So the second JavaScript code is stored on the blockchain. So this technique is called the ether hiding technique. So the threat actor just used the blockchain to store some JavaScript obfuscated code, which is retrieved by the compromised website. So when the second JavaScript code is executed, it will contact the ClearFake command and control server, so also named C2 server, to get a fake HTML. So the fake HTML is the fake pop-up display to the user with the click fix tactic that says to the user, there is an error, please copy this code and execute it to resolve this error. And if the user does that, it will, of course, infect the system with some malware. So I hope this figure is crystal clear. If not, just remember that the ClearFake framework uses the blockchain to get a payload and also communicates with an adversary's infrastructure to get the HTML code. We will use it later to track this threat. And by analyzing this malware in July 2024, we found an API documentation on the threat actor infrastructure. And this API documentation lists 3 endpoints. So the first one was for the malware to get the HTML code, so well. The second one was for the threat actors to update the malware to deliver, so using the ClearFake framework. And the third one was a statistic for the threat actors. So the threat actors can get some statistic about the number of visitors on the website compromised by ClearFake. And in July 2024, when I requested the server for 24 hours, there were around 200,000 visitors on the website compromised by ClearFake. So these numbers are quite huge for a cyber criminal campaign, and we estimate that tens of thousands users were compromised by the malware delivered by ClearFake. So this is a huge campaign, and that's why we are focusing on it at Sequoia. So let's conclude about this threat. So this ClearFake campaign uses a universal social engineering tactic, as it implies the web browser and every user use a web browser. And second, it reaches a large audience, as the threat actor use multiple thousands of compromised WordPress. So the threat actor doesn't have to pay for an infrastructure and use several tactics such as SEO poisoning or malvertising. They use an already existent infrastructure as it compromises thousands of WordPresses. So that's it for the ClearFake malware. Let's now focus on a social engineering tactic which emerged in 2024. So ClickFix is a tactic that involves displaying fake error messages in web browser to deceive users to copy, paste, and execute a malicious script. So we already seen this tactic with the ClearFake variant. Let's see another prominent campaign. So this one uses a fake reCAPTCHA challenge. So when the user browses this malicious web page, and if the user wants to resolve this challenge, it will then press Windows plus R to open the Windows terminal, will copy and paste the command. So the command is stored into the user clipboard data if the user clicks on the resolve button. And after it will, of course, execute the malware. So in this case, the Luma stealer malware. So this tactic emerged in in March 2024, and is now used by many threat actors in the wild. So we can explain that for several reasons. The first one is that the user doesn't download a malicious file from the web browser, so the web browser security features are bypassed, and the web browser doesn't check for the clipboard data in which there is the malicious command line. And second, I think that many users are now aware that downloading and executing a file from a random website can be dangerous, but the user don't really know what is a script, what is a command line, what is a Windows terminal. So many organization employees are not aware about executing a random script in their Windows terminal. So for this reason, I think this click-fix social engineering tactic is really effective for the threat actors. So just a small timeline since the emergence of this click-fix tactic. So it was first used in March 2024. Then the ClearFake variant used it in the end of May 2024. Since August, many threat actors adopt this tactic for their distribution infrastructure to replace the usual download file from the website. And it is interesting to note that not only financially motivated threat actors are using it, but also since October 2024, a state-sponsored threat actor, so which is APT28, so a Russian threat actor, that used this tactic in a campaign that targeted the Ukrainian local government. So it is interesting to see that this tactic was adopted by many cyber criminals, but also by nation-sponsored threat actors. So now we finished with the click-fix tactic. Let's enter in the third part. So it is my daily job at Sequoia. It's to track the adversaries' infrastructures, to monitor many threats and different campaigns. So first, why do we track the adversaries' infrastructures? So mainly to collect some cyber threat intelligence about the threat actors. And it also includes the collection of indicators of compromise. So indicators of compromise, also named IOCs, are mainly domain names, IP addresses, URLs, file hashes, and more. So our goal is to collect IOCs to do some proactive detection, for incident response, for traffic filtering, traffic blocking, but also to do some research for new or prominent threats. And how do we do that? So we are using scanning tools mainly. So when we find a new adversary's infrastructure, we will try to find some fingerprint of this infrastructure to eliminate the whole adversary's infrastructure. So by fingerprint, it is the HTTP data, HTML data, domains with, TLS certificate, and more. And when we have a fingerprint data which is characteristic of an adversary's infrastructure, we will use our tools to scan every internet and get every server that belongs to the adversary. So we are using internal tools such as scanning tools, automation scripts, and so on. and also external tools that you may know. So there are OSINT services such as Shodan, Census, VirusTotal, and so on. So that's why and how do we track the adversaries' infrastructure. So now let's see how do we apply this methodology to the threat we expose in the second part. So for GreHack, we can track the GreHack infrastructure using the compromised website, but also the C2 server. So let's start with the compromised websites. So as we have seen in the second part, the website compromised with GreHack will communicate with a specific domain to download a JavaScript library for blockchain interaction. It will then interact with the Binance blockchain, and then with the GreHack command and control server at a specific endpoint, which is /endpoint. So by correlating these three characteristics, we can list every website compromised by GreHack and scanned by URL scan. So as you can see on this slide, since June 2024, there are more than 4,700 websites which were compromised by GreHack and also scanned by URL scan. So here for the first part, then we would like to track the GreHack C2 server to do some proactive detection. So in October 2023, when we analyzed the GreHack malware, we found that every GreHack C2 server used the same TLS certificate. So we are easily unveiling the whole GreHack infrastructure by searching for servers that use this common name from the TLS certificate. So on the left, you can see the common names used over the time. So the adversary, the threat actors, change every 2 or 3 months. And on the right, you can see the active GreHack C2 server as of last week. So there are 7 active C2 servers. So this methodology is relevant as when an adversary changes the C2 server using these scan engines which are scanning several times a day the whole internet, we can get directly the new C2 server of the attacker, sometimes before they are using this C2 server. So here is for the TLS certificate. We have also another methodology. So as I explained, the GreHack framework will download a JavaScript code from the Binance blockchain. So we can do the same. The attackers are using some wallets, and by monitoring the transaction from these wallets, we can get the input data from every transaction, deobfuscate the input data, and get the GreHack C2 domains. So on the left, you can see a transaction related to the GreHack malware. You can see the input data on the bottom. And by using this input data, by deobfuscating this input data, we can get the domain name. So the one used last week, which is dareka4te.shop. So this is another method to track the GreHack C2 server using the blockchain. So the goal when we are tracking adversaries is to multiply the tracking methods to follow to monitor the infrastructure, even when it changes from, for example, for the TLS certificate. If we have multiple methodologies, we can track the changes. So here we are for the GreHack threat. Let's discuss about the malvertising clusters. So in the first part, I show you some malvertising cluster. The malvertising clusters usually impersonate some legitimate website to distribute some malware. So the goal is to find the malicious websites impersonating legitimate ones. So for that, we will search for websites that use the same HTML titles, content, favicon, or else, but which are not hosted on the legitimate domain name. And by applying this methodology to multiple software websites which are impersonated by threat actors, we can proactively find new malicious domain names. So we apply this methodology for Advanced IP Scanner, AnyDesk, Bitwarden, and so on. So here is an example to illustrate this methodology. So for the Advanced IP Scanner tool, the title is Advanced IP Scanner Download Free Network Scanner. So by searching these keywords on multiple search engines such as Census, Public WW, URL Scan, and ONIF or else, we can find every website that use this title, but which are not hosted on the legitimate Advanced IP Scanner. So on the left, you can see last week there were 6 active domain names that impersonate and also typosquat Advanced IP Scanner. And on the right, you can see the result for URL scan, so over the last past years. So on URL scan, we have more than 300 malicious domain names that impersonate and typosquat Advanced IP Scanner. And what are the results of this methodology? So we are applying this methodology since January 2023 for dozens of legitimate websites. And we found more than 1,300 domain names and more than 100 servers. And it allows us to do some proactive detection in our customer environment, but also to find undocumented campaigns. So some example on the slide, we found a campaign that distributes the net support rat with hundreds of domain names. And we allegedly attribute this campaign to Fin7, which is a financially threat group active since many, many years. We also find the nitrogen campaign I discussed in the first part, so the one used by the Black Cat ransomware affiliate to gain a foothold into the victim networks. And we found many other campaigns that we attributed to some threat actors or some else that we can't attribute. So we can mention some campaigns that distribute pre-ransomware botnets, some loaders, some info stealers, and more. And my last example is for the ClickFix cluster. So as I tell you, in March 2024, this ClickFix tactic emerged. So our goal at Sequoia was to find threat actors or campaigns that leverage this ClickFix tactic. So we are using the same methodology as I explained before. So we are searching for ClickFix keywords on website, but also on files. So we will use the usual search engine, but also VirusTotal to find files using YARA rules. And using this methodology, we found numerous new clusters which adopt the ClickFix tactic. So I can mention some of them. A cluster of fake Google Meet pages, which we attributed to a sophisticated cyber group. I will explain it in the next slides. A cluster of fake Facebook web page. So we discover a new sophisticated loader which is under analysis in our team. We are reversing this malware. And other cluster that impersonate some brands and distribute numerous malware. And for the end of my talk, let's focus on the first cluster that impersonates Google Meet web pages. So this is the lure, usual ClickFix lure. And this is some domain names on the right associated with this fake Google Meet cluster. And our goal at this time, it was in September 2024, it was to find which threat group is using this fake Google Meet cluster in which campaign. So we dig into the adversary's infrastructure, and we found JavaScript code, which is the backend code used by the attackers to exfiltrate the fingerprint data from this cluster, from the visitor going on these fake Google Meet web pages, and which exfiltrate this data to a Telegram bot. It is quite usual for Russian-speaking threat actors, and to a MongoDB. So by dumping and investigating the Telegram bot and as well as the MongoDB, we found some more interesting information. So first, we found a chat in the Telegram bot. So it was written in Russian, of course, but we translate it. And it was a threat actor, Spark Hash, who explained to another threat actor how to use this cluster. And using this information from the Telegram bot and the MongoDB, we were able to find the threat group on Telegram, a Russian-speaking threat group, which is named as Quamcarteo. And it is a threat group specialized into targeting the cryptocurrency user and NFT user. So using a fake persona, I was able to join the group and use the Telegram bot to generate a new Google page, malicious Google page that used the click fix tactic. So here is how we attribute some cluster to known or unknown threat groups. If you want to know more about our work, our research, do not hesitate to visit blog.sequoia.io. We publish regularly on cybercrime, but also APT, Advanced Persistent Threats groups. And that's all for me. Thank you for listening to me. And if you have any questions, please ask.